In this video, we want to solve a rational equation. We have 11 over 2x squared plus x minus 15 equals 5 over 2x minus 5 minus x over x plus 3. So certainly plenty going on in this example. Let's first start by factoring this trinomial so we can start looking for a least common denominator. And I'm going to make a lucky guess. Right? We can use trial and error, we could use the diamond method, but you know what? I'm thinking it's probably 2x minus 5, x plus 3. Let's see. Why would I think that? Because these are the other two denominators. And when we FOIL this back together, maybe you can do a quick FOIL on this. You can see that indeed it comes to this trinomial. So this is in fact the factored form. All right. We can rewrite this here then as 11 over 2x minus 5, minus 5 times x plus 3 equals 5 over 2x minus 5 minus x over x plus 3. Now we need our LCD because we're going to clear fractions by multiplying both sides by this LCD. Get rid of all those fractions. Okay, so let's do it. Looks like the LCD here is, well, the way you find the LCD is you start with the first one. Okay, so 2x minus 5, x plus 3. And then you go to the next one and say, what do I need to add into the LCD to make sure that this denominator is included? Well, it's already in there. So this one's good to go. 2x minus 5 is included. Then you move on to the next denominator and you say, well, what do I have to add to my LCD to make sure that's included? Well, look, x plus 3 is already in there, so that's good to go. And we have our LCD, 2x minus 5 times x plus 3. All right, so the key next is to multiply both sides by this least common denominator. That will get rid of all denominators. All right, so here we go. I'm going to multiply the right by 2x minus 5 and x plus 3, and the left by the same thing. 2x minus 5 times x plus 3. Okay, well on the left, all of this immediately cancels out, and we're just left with 11. That's nice. On the right, there's a little more to it. When we multiply through to this term, so we distribute this through to both terms here, when we do it to the first one, the 2x minus 5's cancel, right? And that leaves us with 5 times x plus 3. Okay, when we multiply to the second term, the x plus 3's cancel. That leaves us with x times 2x plus 5. So minus x times 2x minus 5, minus 5. And what do you know? We have gotten rid of all those denominators, and now we just have an algebraic equation to solve without any crazy denominators. Okay, so let's do it. Let's see what we get here. 11 equals 5x plus 15, distributed the 5, minus 2x squared plus 5x. All right. Well, these 5x's combine to get 10x. Anytime you see an x squared and you're trying to solve, remember that x squared likes to be set equal to 0. X squared, then you'll have a bunch of stuff, but if you have x squared on one side, you need to have 0 on the other side. That's the key. So I'm thinking let's get everything on the left-hand side of the equals. That'll give us a positive leading coefficient. That's not 100% necessary, but it's useful. Okay, so I'm adding the 2 over there. So 2x squared over there, 2x squared. I'm going to subtract the 10x off from both sides. That gives us a minus 10x. And then we have an 11, but I'm going to subtract off 15 from both sides. So that gives us minus 4 equals 0. And we're going to need to use the quadratic formula. That's no secret, just by the title of the video. But don't do it yet. right? Always factor out the GCF and get rid of it before using the quadratic formula. It'll save you a lot of time and effort. You could go straight to quadratic formula. It's not going to give you the wrong answer. It's just a lot harder. So instead, I'm going to factor out a GCF, which is 2. That gives us x squared minus 5x minus 2. Look at that, equals 0. And then we can just divide it away since it's a number. You wouldn't want to divide away a variable like that, but for a number, that's fine. Okay, so x squared minus 5x minus 2 equals 0 is our new quadratic equation for which we use the quadratic formula. Okay, so we just need to identify a, b, and c. There's no term here, so it's really a hidden 1, and that's our a. Our b is negative 5. Our c is negative 2. All right, so let's just plug everything in and see what happens. This will solve this equation for us. We have x equals, all right, negative b, so negative negative 5, plus or minus the square root of b squared, so negative 5 squared minus 4 times a, which is 1, times c, which is negative 2. All over 2 times a, which is 1. Okay, so let's clean this up a little bit. That gives us positive 5 plus or minus the square root of 25 plus 8 is 33. All right, all over 2. And there you go. There's no more simplification that we can do. 33 is simply 3 times 11, so nothing comes out of the radical. So there's the answer. Let's try another one of these. For this example, we have 5 over x minus 3 plus x over x plus 3 equals 19 over x squared minus 9. We want to solve this thing. We need to get rid of those denominators. So let's multiply both sides by the LCD, which we need to find by first factoring. And look, x squared minus 9, that factors as x plus 3, x minus 3. Okay, so that's what it really is. And now we can look at both sides and find our LCD. You take the first one, add that in, x minus 3. Then you go to the second one. Well, is x plus 3 included? No, it's not. So let's add that in, x plus 3. Then we go to the third one, x plus 3, x minus 3. Is that whole thing already included? Well, yes, it is. X minus 3, x plus 3 is already in there. So this here is our LCD. All right. The idea is to next multiply both sides by the LCD on the top here. That will clear out all these denominators. We call this clearing fractions. X plus 3, x minus 3 here, and this whole side over here. We have x plus 3 times x minus 3. Kind of running out of room there. Okay, so on the right side, these denominators completely cancel out. So we're automatically left with equals 19. On the left side, we distribute this x plus 3, x minus 3 through to both these terms. On the first term, the x minus 3's are going to cancel, right? Leaving us with 5 times x plus 3. On the second one, the x plus 3's will cancel. That leaves us with x times x minus 3. And now all of our denominators have vanished, and we just need to solve this equation. So let's see what this brings us. We have 5x plus 15 plus x squared minus 3x equals 19. We need to get this in the form of a quadratic equation, ax squared plus bx plus c equals 0. Once it's in that form, we can hit it with the quadratic formula. So let's keep working towards that. Let's see here, we have some like terms. There we go, we can subtract, well let's see, so we have x squared, 5x minus 3x is 2x. And then we subtract the 19 from both sides. That gives us 15 minus 19 is minus 4. All of that equals 0. Okay, maybe do a quick attempt to factor it. It does not factor, so let's hit it with the quadratic formula. Okay, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just see what happens here. We have our a is 1, our b is plus 2, and c is minus 4. Okay, let's roll through this thing here. So x equals negative b, so negative 2 plus or minus the square root of b squared. So that gives us 2 squared, which is 4, minus 4 times a, which is 1, times c, which is negative 4, all over 2 times 1, 2a. All right, let's simplify this down. Minus 2 plus or minus the square root of, well, 4, negative 4 times negative 4 is positive 16, and 4 plus 16 is 20. There we go, all over 2. All right, we can simplify this further. 20, when we're looking at rad 20, I'm looking for perfect squares in with 20, so I'm thinking 4 times 5. And then the 4 pops out as a 2. There we go. So this is really negative 2 plus or minus 2 rad 5 all over 2, which now we cancel each one of these terms with the 2 below. So this 2 is going to work on this one and with this one. You never want to just do it on one of the 2 terms. If you're going to simplify, make sure you do it with both of them. Okay, so then for our final answer, I'll go over here with it. We have negative 1 plus or minus root 5. So really that's 2 answers for the price of 1. Plus or minus is 2 separate solutions. There you have it.